Good afternoon. Thank you for joining one of the Beaumont webinar series. This one is brought to you by Beaumont Development. My name is Eric Mather. I will be your presenter today. I am going to be showcasing Moldflow Insight Analysis Setup. So what I'm showing is by using Fusion 360 along with Moldflow, I'm going to show you how I will set up a cool fill pack analysis. So I will model in the cooling lines, the feed system, the part, set the process parameters, so on and so forth to get the simulation started. A little bit of background on me. I started my Beaumont Technologies internship in the fall of 2012. I did a co-op period between 2012 and 2014. Beaumont offered me a full-time position. I took that full-time position in 2014, doing schooling off on the side. So eventually I did graduate at Penn State Barron in 2017 with my Plastic Engineering Technology degree. Since then, I have acquired my Autodesk Expert certification in 2020. I head up Moldflow support and consulting here at Beaumont, and I work with the engineering consulting team. So if you have ever had a question with Moldflow support, had an issue with the software, and you reached out to Beaumont, you most likely have dealt with me. In my first video that I'm going to show is I am going to be showcasing opening mold files in the Fusion 360 program. I'm going to use Fusion 360 to simplify, combine some parts, remove some letterings, export that from Fusion, import that into Moldflow Insight, and then mesh. So as you can see, I got my project directory. I date my folders accordingly. That keeps me a little more organized. Right now I'm just going through hiding a lot of the blocks, and I'm looking for that part, runner, and feed system. As you can see, there's multiple bodies in this mold file. This is pretty common. We usually don't receive everything from the customer as one solid body. And in this case, my sprue geometry, I just have the bushing. So I'm gonna go into the surfaces and unstitch this sprue bushing. And what I'm doing is I'm deleting and simplifying these surfaces. What this allows me to do is then cap the ends of the sprue bushing and easily stitch them and convert them to a solid body. So you see me capping the ends here. I'm then going to stitch. Along with that, now that it is a solid body, I want to remove any lettering. Now what you'll see is I've accidentally deleted just the faces of those lettering. That's because I was under the surface command. So once I switch over the solids, because that's already a solid body, and I delete that lettering, Fusion will automatically update accordingly. Next, what I have to do is combine all of those bodies. And what you can see, I use the combine tool. I have one solid body, and I'm going to export this as a step file. I'm going to name it accordingly. I'm just going to call this part and runner. Once this file is exported, I'm going to switch over to Moldflow Insight. I am importing that part and runner step file, and I'm going to start as a dual domain. What I like to do is get an adequate mesh on my part, and then I prefer to put that surface mesh on there, check for any issues within that surface mesh before converting to a 3D. So what I'm doing is I'm just previewing, and when you hit the preview button, you can kind of visualize where the nodes will be. And by changing edge length, instead of using auto sizing, I can then change this value and tighten my mesh up or loosen it. Now what I noticed is that I don't have extra refinement at my gate. And with this being a tunnel gate, I'm concerned possibly with higher shear rates. I want to tighten the mesh up in this area. So what I'm doing is I selected the faces of my CAD geometry. I'm just going to right click and go to define mesh density, add it to a mesh control, and just like before, I'm going to add these surfaces. I'm going to use about a 0.5. I'm going to hit the apply, take a look at it, and I've decided I want to go just a tiny bit tighter on that mesh. Everywhere else seems adequate. The higher the element count, the longer the run times, and sometimes it's not actually beneficial to have higher element counts. So I'm launching the Simulation Compute Manager. I'm going to mesh using Synergy. And a little off-screen magic, speed up the process a little bit. Now that my mesh is complete, I want to ensure that I don't have any aspect ratios, overlapping sections, and you can see that that did in fact create extra mesh density at that height. So as I'm going through my checklist, aspect ratio free edges, overlaps, some collapsed, everything is not popping up with errors. So then I'm just going to purge some nodes, remove some extra properties in the background. Now what I like to do is put a node directly in the center of my sprue. So by using kind of that geometry line, I'm going to insert a node between coordinates, switch back to the mesh tool, insert a node on that triangle, and then I'm going to merge, excuse me. I'm going to swap an edge, and then I'm going to set my injection location. Now I'm ready to go to 3D mesh. I also like to do is I like to turn my triangles to a solid coloring. This helps with performance, visualization, rotating my models, so on and so forth. So I'm going to save my file. I named it DD for dual domain. And then I'm going to duplicate. I like to keep a dual domain part geometry at the top of my model tree. This allows me to make on-the-fly changes. I can revert back to that dual domain, make some changes if needed. And right here, what I'm doing is I am meshing to 3D. Again, I'm going to mesh use Synergy. And again, a little off-screen magic. We'll just speed this up. Once my mesh is complete, now I have a tetras in my layers. Again, I prefer to change these to solid. This helps with my computer speed. Now removing layers, I need to select my injection cone, and I'm just going to move this to a cold runner layer. I have a cold runner and a part geometry, so what I want to do is I want to select my cold runner, and I want to set the associated properties. So right now I'm selecting through the thickness, slightly rotating that part to get kind of a straight line. I'm going to assign that to my cold runner layer. It will default back to kind of the shading with the edges. So I'm going to switch that back to solid. Then I need to set this to a cold runner property. The default color for cold runners is kind of this green, brighter green. So now I have my part and my cold runner in my model, and I'm meshed. The next video I'm going to show you is just continuing the process. I'm going to go back to Fusion 360, and I'm going to isolate my cooling lines, export them into Fusion, and then use the cooling line extraction method. So switching back to Fusion 360, I'm able to undo everything that I previously did to get me back to my full mold assembly. Now I was fortunate that the customer supplying this file sent me the cooling lines as 3D cooling lines. And I'm just going through and I'm hiding everything that is not cooling line related. So I'm trying just to isolate those cooling lines. So I'm going through hiding a lot of these plates in the steel. Rotating as I go. I'm looking at the inlets and outlets, making sure I'm not missing anything. Kind of using that banding select, I'm able to quickly highlight those areas. Now, a little bit of a process, but in the end, it is certainly worth it. So at this point, it's kind of clear enough that I'm going to start selecting my path of my cooling lines. So I like to start with the inlet. I started with the cavity side. And kind of just rotating, working through, selecting that path. I'm going to do the same for the core side. And I'm just about finished here. And I'm going to select that insert as well. Now I'm holding down control and selecting quite a bit of these bodies in Fusion. I think it goes without saying it's a little riskier to do it this method, but once I isolate everything, I do have everything there. A lot of times I'll do step by step, but for this example, I isolated everything. Again, exporting as a step file. Once that's exported, I'm going to then switch over to my Moldflow Insight. I'm going to close out of my dual domain and 3D setups, import my cooling lines. And now I'm going to import these as a 3D. By using solid 3D, I'm able to set the properties of my cooling lines to channels and use the cooling line extraction method. So what I'm doing here is I'm just going through and I'm going to select my core, cavity, and slide and name them accordingly. So I'm selecting my bodies. Now you can see I accidentally grabbed a part of that core line. I'm just going to keep going through, creating new layers. So now I have a slide, I have the core, just assigning them. And then last but not least, the cavity. Now I've got only 3 layers I'm looking at instead of multiple layers per body. Highlight everything, assign the properties to a channel 3D. Then I like to go kind of one at a time. So I'm going to start with my slide. I'm just going to go down to the curves. I'm going to use the cooling line extraction. As you can see, I now have these curves. If I right click on properties, the diameters are carried over. I like to name mine to channel 5 because that was the diameter. Now as I go through and select everything, invert my selection and kind of delete anything that I don't need, I notice that this line kind of goes through the other one. So I'm just going to hit backspace. I'm going to create that new line, channel 5. I know the diameter. Create a new layer, call it slide cooling. I'm just connecting those lines, selecting the rest of the coolant flow path, adding it to my slide. Then I'm going to remove my geometry layer. I no longer need that. So then I'm going to move on to the core side. Again, it's already set to a channel property, so I'm able to do a centerline extraction. Again, 10 millimeters was the diameter. I'm going to apply that to all of the channels that have the same properties. And going through one at a time. Selecting my flow path. I like to invert the selection once I have everything selected and delete out any of the unneeded cooling lines. Again, assign everything to a new layer. I call this core cooling. Remove my geometry and move on to the cavity. Again, using cooling line extraction, selecting that flow path for the water. Now I do notice that there is kind of this real small section here. I'm going to replace that line with a straight line, just connecting the two. I don't want any issues with the simulation. Again, adding a cavity cooling layer. I'm going to go up and do create as my channel 10. Select my kind of straight through. Remove my geometry. And now I have my slide, core, and cavity all modeled up. I'm creating a folder called cooling lines. Once I combine everything, I like to stay a little more organized. This also carries over to any MFR files. So I'm going to start by meshing my slide. And I check the place in active layer. What that allows me to do is keep my coin lines, nodes, and beams that are associated with that slide all on the one layer. And I'm going to do the exact same thing for the core. Beam elements take very short time to mesh. Last but not least, the cavity. I'm going to change it to the cooling analysis. What this allows me to do is I'm able to start assigning my inlets and outlets. So I'm going to assign my cavity. I'm then going to assign a new layer for core. The reason behind this is that if I want to implement or use any type of select by properties or run a design of experiments, I'm able to alter each one of those individually. So after I kind of toggle on and off my CAD geometry, everything's been modeled correctly, I'm going to delete those. I no longer need my CAD geometry, but I quickly showed there I'm able to select by properties. Again, just going to rename this, keeping everything organized, and save my analysis. Lastly, I'm going to combine my kind of three models in my model tree there. My cooling lines, my part, my runner files. I'm going to set up a mold boundary. I'm going to select my material, enter some processing parameters, and solve the simulation. So I've got my three different layers. Now I'm duplicating the 3D one. The reason behind that is that what I've noticed is adding the 3D part and runners to, let's say, the cooling lines sometimes breaks the CAD geometry link. And in this case, I want to keep my CAD geometry associated with my part and runners. So I just duplicated that, rename it. My naming scheme, CFPW, Cool Fill Pack Warp. And then I'm going to go ahead and add my cooling lines. What's really nice is everything was in mold position when I exported and imported. So everything lines up accordingly. I'm going to change this to a Cool Fill Pack Warp simulation. And what I'm doing is I'm using the scale down below to get a mold boundary. So I switch to the geometry tab, grab my mold block wizard, and by using that scale, X direction 350, Y 300, and Z 350 millimeters. I like to move those elements down under my geometry tab, or my geometry layer. I'm able to turn on and off that mold boundary. And what I'm doing here is I'm starting to select a material. So some other features we're allowed to search by is filler, filler weight, description. But you can add any feature that is inside of a UDB file, any type of location. And what I'm doing is I'm adding the quality criterias for the Moldflow tested materials. So I'm adding filling, packing, and warpage, and I'm changing them to the gold rated properties. So for this simulation, I'm looking for a highly characterized material. I'm looking for a glass filled material, about 20% glass fiber content, and I'm looking for I just typed in nylon for now. I'm just going to expand this, and it looks like I have right around 37 that meet that criteria that I've added. And I certainly can add more criteria or remove it, but you can see that the quality indicators to the right, I can sort, and I can take a look at any of these materials. I can also compare the materials, export the materials from the database, so on and so forth. So I believe for this one, I'm going to use this ABS blend here. It does have my CRIMS data, so I can run the stamp model for verification purposes. I'm going to click on this material. Now I'm going to right click on the material and take a look at the details. And I see that a recommended mold temp is around 140 degrees Fahrenheit. I'm going to go ahead and select my inlets, set that temperature to 140 degrees. Go into my process settings, take a look at my injection pack, cooling time. I'm going to round some of these numbers. I can choose automatic for the fill control. I'm going to set an injection time to right around 2 seconds for this part. My velocity pressure switchover I'm going to do by a percentage, but I'm going to leave everything by a percentage for the pack and hold. I also want to isolate my cause of warpage. What this allows me to do is take a look at what's causing my primary cause of warpage, whether it be orientation effects, maybe it's the cooling lines, or maybe it's my part geometry, just my shrinkage. So I'm going to start the simulation. And again, off-screen magic, just for this purpose. Starting the simulation. Simulation is finished. By taking a look at some of my logs here, I'm able to see that my cooling took only about 15 minutes, actually 16 minutes for the elapsed wall clock time. Fill and pack only took an hour and 7 minutes, and warpage took 12 minutes. So right around an hour and 30 minutes, give or take, maybe 2 hours for this simulation. I appreciate your guys' time everyone's time for joining this webinar. We will be opening the floor to questions. Here is my contact information as well as the Beaumont Moldflow support. If you have any questions or concerns, you certainly can reach out to me. Thank you.